Let's start you off pretty easy. First problem, let's just find the square roots. So before I do any of that, I need to change this complex number into its polar form. So you need to find the modulus and the argument, and then write it as modulus cis argument. Don't forget to add the 2 pi k so you get all your argument answers. So pause the video, find the modulus and argument, come back and with it written in polar form to check and see how you did. Check what you got with what I got. So writing z in polar form, I got 4 cis 2 pi thirds plus 2 pi k. Now, in this problem, we want to find the square roots. So I am going to do the square root of the modulus. And I'm going to take the theta, divide it by that root number, as well as my 2 pi k, divide it by that root number. That's our rule for finding roots. So square root of 4 is 2. 2 pi thirds divided by 2, you could keep switch flip times by 1/2. Your 2's cancel and you just get pi thirds. So it gives me pi thirds plus 2 pi over 2 pi k. So here is my roots. Now, because it's square roots, that means I should have 2 answers. The first one is my regular argument. So regular modulus, regular argument. The second one is when I add my pi to my argument. And I would keep adding pi for however many roots I need. In this case, because it's the square root, I only need 1, 2 answers, so I only need to add pi once. But remember, if you add the cube root or the 4th root, you would keep adding whatever it is till you get 3 and 4 answers, whatever you need. So write this out, 2 cosine of pi thirds plus I 2 sine of pi thirds. 2 cosine of, that's going to be 4 pi thirds when I add those together. And once again, this is just unit circle. Cosine of pi thirds is 1/2. Sine of pi thirds is root 3 over 2. So this gives me 1 plus I root 3 for my first root. And cosine of 4 pi thirds is negative 1/2. Sine of 4 pi thirds is negative root 3 over 2. So that gives me negative 1 minus I root 3. And those are your 2 square roots. So to summarize this whole process, we wrote it in polar form. We did the rule. And then we found however many answers as whatever root I have. So since this was the square root, I found 2 answers. Let's try another one. This time we're going to find the 4th roots. Now this is z equals negative 16. So we could also write that as negative 16 plus 0i. So to start you off, same thing. Find the modulus and the argument of this complex number so you can write it out in polar form. Then I want you to go one step farther. Try performing the rule on your own this time. This time we're taking the 4th roots. So take the 4th root of the modulus and then divide your arguments by 4 to see if you can come up with this part on your own. So basically what I want you to do is all of this part, do that on your own for this 4th roots problem, and then come back to check your work and see how you did. Let's check your work. So here I have z is 16 cis pi plus 2 pi k from the modulus and the argument. Then I perform my rule. I'm taking the 4th roots. So I take the 4th root of the modulus, divide the argument by 4 to give me 2 cis pi fourths plus pi halves k. Now remember, this is the fourth roots, so I should have 4 answers. My first one is just my regular argument. And then for each of the consecutive ones, I'm adding pi halves to the argument. So as you can see in each one, I added one more pi halves until I got to my 4 fourth root answers. Now, we've had plenty of practice with writing this all out as 2 cosine pi fourths plus I 2 sine of pi fourths, so I would like you to take it from here. Write all of these out. They should all be unit circle problems. You shouldn't need to use your calculator at all. And then simplify them out to get what your 4 actual fourth root answers are. Pause the video, try that out, and then come back to check your work. Check your work. So here I had 2 cosine of pi fourths plus I 2 sine of pi fourths simplified to this. Now, if you wrote cosine of pi fourths as root 2 over 2, your answers would be root 2 plus I root 2. Totally fine. They are the exact same decimal if you put them both into your calculator. You just use the other form of 1 over root 2. Like I said, totally fine. But then you also get second root, third root, and fourth root. Once again, yours might look a little different if you used root 2 over 2 instead of 1 over root 2. But both are totally good. So that was a little bit more of a complicated one. We had 4 answers for the fourth root this time, but I wanted to show you one more representation of just how that looks. If we graphed all 4 of those roots in the complex plane, notice that it has a radius of 2, which was our modulus, and it's a circle that has been split into fourths because it is the fourth root. So that is just visually what's happening here. We only have 2 problems left, and I'm going to leave these more and more up to you to do. So here we have the 3 cube roots of this. It's getting a little more complicated. Start the same way by finding our modulus and our argument, writing it in your polar form, and then doing your cube roots rule. Let's go to that point, get the cube roots rule, and then we'll check our answers at that point. Then we'll actually write out our 3 cube root answers. So just get to our cube roots rule point, and then we'll come back to check your work. Let's check your work so far. I got that my modulus is 2 and my argument was pi fourths. So I did my rule, since we're doing the cube roots, take the cube root of the modulus, divide my argument by 3. Here's my cube roots rule. Now, I know that I should have 3 answers here. So the first one is just my regular argument. The second one, I'm going to add onto my argument. And the third one, I'm going to add onto my argument twice. So, cube root of 2 cosine of pi twelfths plus I cube root of 2 sine of pi twelfths for our first one. For the second one, cube root of 2 cosine of, if I do pi twelfths plus 2 pi thirds, that gives me 3 pi fourths, plus I cube root of 2 sine of 3 pi fourths. And the last one, if I have pi twelfths plus 2 pi thirds plus another 2 pi thirds, that gives me 17 pi twelfths. Now, the reason I'm actually writing you out with this one is this would be a calculator problem because you can't do cube root of 2 in your head. So at this point, let's get your calculator out, put that part into your calculator, round it to 2 decimals, then put this part into your calculator, round it to 2 decimals. If you do that, you would get 1.22 plus I 0.326, and that would be your first answer. So knowing that this is a calculator problem, plug these pieces into your calculator to come up with your other 2 cube roots, and then come back to check your decimals and check your work. Check what you got with what I got. If your answers are different, it might be because your calculator is in degree mode. Make sure your calculator is in radian mode because all these angle measurements are in radians. Then you should have no problem getting what I got. Now, we have one more problem left to do. The 5/5 roots of z equals 1. And I would like you to try this one all on your own. So write it in polar form, apply the rule, and then find all 5/5 roots. And I will warn you for this one, these are not unit circle angles that you'll get. So feel free to put them into your calculator and get decimal answers. So try this one all on your own from start to finish, and then come back to check and see how you did. Let's check your work from start to finish. Here are my 5 answers. If you didn't get those answers, feel free to pause the video at this moment so you can look through all my work and find out where you went wrong. If you did get those 5 answers, congratulations, you're doing fantastically. One last thing before we end this video, I have created this little table down at the bottom of your notes that walks you through everything we learned in this lesson in 6.4, talking about converting it into polar form, using your modulus and your argument, using whatever rule you need to, whatever it's asking you to do, multiply, divide, exponents, or roots. Then write out your new polar form and simplify it into the individual pieces so you end up with your answers. So that is everything for complex numbers. You are done with chapter 6. In the next chapter, chapter 7, we'll dive into something completely different, which is vectors.